Alright, so in this video we're going to look at some more cross sections. We're going to look at these two shapes here. So part C, we have the isosceles right triangle. So let's go ahead and find the volume for this figure here. So again, remember it's the area of the base times the height. Well, the area of the base here is a triangle, and the area of a triangle is 1/2 the base times the height. Well, the base here is given by s, and the height is also s, so s times s is s squared. Then we also have to multiply by this width here of delta x to get the volume, so we multiply by delta x. Now that is pretty much it. That is the volume for just one of these figures. Imagine if you wanted to accumulate infinitely many, then what we would have to do is integrate. So we would integrate from a to b. Now the 1/2, I'm going to go ahead and write it out front, and we have 1/2 s squared dx. And that's pretty much it for the isosceles right triangle. Another thing to keep in mind is if we go back a little bit and we look at the formula that we had for the square. So when we were talking about the square, we ended up with the formula, the integral from a to b of s squared. Well, it's kind of the same. If I cut this in half, I have an isosceles right triangle sitting in that square right there, if I just cut that diagonal right there. And so it makes sense that our formula is going to be half of the volume for a square. And if we go back to our formula for the isosceles right triangle, we in fact have half of the volume of a square. So let's go to the semicircle now. So if we have a semicircle, I've already taken I've already labeled the diameter s. So that means that the radius here is going to be 1/2 of s, right? Whatever s is going to be half of that. So again, the area for this circle, so we start by finding the area of the base, and the base here is a circle. Well, the area of this circle is pi r squared, but we're not talking about a full circle, we're talking about half a circle. So it's going to be half the area of a full circle, so half pi r squared. Now what is r for our picture here? Well, r is just the 1/2. R is just the 1/2 s. So the area is going to equal, well, 1/2 pi, and then it's going to be 1/2 s squared. And if we simplify this a little bit, we end up getting that the area is equal to 1/2 pi, and then we're going to have 1/4 s squared. So 1/2 squared is 1/4, s squared is just s squared. And then if I multiply the 1/4 and the 1/2, we end up with that the area is equal to pi over 8 s squared. So that's the area. Again, if I want the volume, all I have to do is just multiply by delta x. So it turns out that the volume is going to be the area, which is pi over 8 s squared delta x. Now that's just the volume for this one semicircle. If I wanted to integrate, or if I wanted, to accumulate infinitely many of them, then all I would do is integrate. So I'm going to write the pi over 8, and then I would integrate from a to b, and then we have s squared dx. And that is it. These are the four shapes that we're going to focus on in this section. In the next video, we'll actually look at an example where we actually put all this stuff together.